your channel Knowledge of Friends. Subscribe to your channel and click the bell icon for the latest update. Today we're gonna start discussing about your physics for class 11, and that is very important one. In terms of physics for class 11, that is your class 43rd, which is we have to cover up here. In 43rd class we had done lastly, that is your 42, and where we had started with the friction, and where we have discussed about the relative motion as well. That is it is in motion, but that is relative motion, that can be the friction force that opposes. All that in the detail we had discussed. You can go ahead in the last classes, you will find out the videos as well. Now in today's class, 43 class, we'll start discussing about the unit 5, which is the laws of motion, and that's what we have to cover up. In terms of laws of motion, we'll start discussing about the numerical, and before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and you can also enjoy the video as well. The question is, that is the 7th question of this unit, and the first question of this particular class. The question is, determine the maximum acceleration of the train in which a box lying on its floor will remain stationary, given that the coefficient of static friction between the box and the train floor is 0.15. Let's go for it. Determine the maximum acceleration of the train in which so for that it will go in which a box lying on its floor will remain stationary given that the coefficient of static friction between the box and the train's floor is 0.15. Now we find out the solution for the same, and that we go for it. So here we go. Since the acceleration of the box is due to the static friction ME equals to Fs is less than equals to mu S, that is mu S N G. So that is A is less than equals to mu Sg, A max equals to mu Sg, that is 0.15, into 10 meter second inverse square equals to 1.5 meter second inverse square, that we get as an answer here. Now we find out another question we did here. In today's class we'll discuss this next question, that is your the 8th question as well, which is related to it only, about the friction. And you know, friction by definition is a component of the contact force parallel to the surface on contact, which opposes impending or actual relative motion between the two surfaces. You have to note that it is not motion but relative motion. Now we have another question, that is another is your 8th question. And although the question we have, a mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until an angle theta equals to 15 degree with the horizontal, and that the mass of that begin to side, and what is the coefficient of static friction between the block and the surface. That is the question here. So for that you have to find out. No worry, you have to go for it. Let's find it out. A mass of 4 kg rest on a horizontal plane. The plane is gradually inclined until at an angle theta where theta equals to 15 degree with the horizontal the mass just began to side. What is the coefficient of static friction between the block and the surface? Now find out here. That is CO theta. Here an object is placed. This is normal. Here it is Fs. Here it is mg sine theta. Normal is being extended, that is mg cos theta. This is making an angle. This is mg, which is theta. Okay, so you can just make it a this is being the side B and this is A. It makes a sort of a triangle. Now we'll go for solution here. So let's go for it. And that we have. So here the forces acting on a block of mass m at a rest of an inclined plane, where in the first way that the v mg acting vertically downward, and the normally force Newton of the plane and the block, and the static force F is opposing the impending motion. So all of that where gradually in an equilibrium, the resultant of these forces must be zero, resolving the weight of mg along the two direction that will be that is being shown here. Mg sine theta fs and mg cos theta is Newton and here. So let's go for it and let's figure it out. So the first point, the weight mg acting vertically downward, you can see there. The second is that you have to remember on an inclined plane that the normal force N of a plane on a block, and the third is that the static fractional forces Fs that opposing the impending motion. So for that, mg sine theta equals to Fs, mg cos theta equals to L. As theta increases, the self-adjusting friction force Fs increases until theta equals to theta max. When Fs achieves its maximum value, which is Fs max equals to mu s. So therefore, tan theta max equals to mu s, or theta max equals to tan inverse mu s. When theta becomes just a little more theta max, there is small net force on the block and begins to slide. You have to note that theta max depends only on mu s and is independent of the mass of the block. So for theta max equals to 15 degree and mu s equals to tan 15 degree, that is 0.27. That we get as an answer, and that is the right answer for this question. Now we go for another one, and that is the another important question which is coming towards it. That we have your question. So that question I will be giving you as an homework, because if we do that it will be exceeding. So that we'll do, and after that we'll bring up the rolling motion friction as well in the next coming class, and we'll be going to end up friction, and then we'll discuss about the circular motion as well. So the question is, what is the acceleration of the block and the trolley system shown in the figure there that has been represented? If the coefficient of the kinetic friction between the trolley and the surface is 0.04, what is the tension in the string, where you have to take G equals to 10 meter second inverse square, and neglect the mass of the string as well. So for that you have to do it, and other than that I'll just give you some of the questions related to it that you have to solve, and which is of course be an important one. So the question has been as follows: a constant force acting on a body of mass 3.0 kg, which is 3 kg, changes the speed from 2.0 meter second inverse to 3.5 meter second inverse in 25 seconds. The direction of the motion of the body remains unchanged. What is the magnitude of the direction of the force? This is the sixth question, which I had given you 5 questions in the last classes. The seventh question, other than that, is a body of mass 5 kg is acted upon by the two perpendicular forces 8 Newton and 6 Newton. Give the magnitude and direction of the acceleration of the body. The eighth question is, the driver of the three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to the rest in 4 just in time to save the child. What is the average retarding force of the vehicle? The mass of the three-wheeler is 400 kg and the mass of the driver is 65 kg. Ninth question, a rocket with a lift of mass 20,000 kg is blasted upward with an initial acceleration of 5 meters second inverse square. Calculate the initial thrust force of the blast. The 10th question, a body of the mass 0.40 kg moving initially with a constant speed of 10 meters second inverse to the north is subject to the constant force of 8 Newton directed towards the south for 30 seconds. Take the instant of the force is applied to be t equals to 0, the position of the body at the time to be x equals to 0, and predict the position at t equals to minus 5 second, 25 second and 100 second. These are the questions, and so that you have to answer it out. Now the rest question we'll discuss in the next coming classes. So I will be giving you more and more questions so that it will be helpful for you as well, to cover up all the topics with their numericals as well. So stay tuned with us, and please like, share and subscribe so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you.